Hello, this is Dr. Nico from FunMove with another video on movement science topics.
Modern training programs combine multiple activities such as sport training, resistance training, and conditioning. Because each activity is measured differently, understanding the overall training performed can be complicated. Different activities generate different types of data. A football training program may produce distance traveled, a resistance training session may generate volume load, while other activities may produce entirely different metrics. Each variable has its own unit and scale, making direct comparison difficult. Training load is an umbrella term used by sport and exercise scientists, physiotherapists, and strength and conditioning coaches to quantify the amount of training performed. It helps optimize programs, monitor progression, and reduce injury risk. However, because different activities generate different metrics, measuring overall training load requires an effective aggregation method. One solution is to standardize each metric. Standardization converts different variables onto the same scale while preserving their relative contribution. Once standardized, the metrics can be combined to create a composite score that represents overall activity in a more meaningful way. A composite score does not replace individual metrics. Instead, it provides a high-level summary that helps practitioners identify trends, compare periods of training, and communicate results more effectively. The individual variables remain available for detailed analysis when needed. In this video, I'll demonstrate the complete process using a practical football example in Excel. We'll start with raw activity data, standardize the variables, and then create a composite score that summarizes multiple activity metrics into a single interpretable value. We will use different standardization methods to convert our raw data into composite scores. The three standard methods are Z-score, T-score, and standard 10 score. The data is organized by activity type and by training load measurements, such as distance, weight, heart rate, and other metrics, per session or day. Some activities and their metrics depend on the measurement units and cannot be averaged, such as running distance during matches and total lifted weights in resistance training. But other metrics are universal and can be combined for different activities, such as heart rate and session RPE score. Here, we have 5 training sessions per week for 4 weeks. Such a training plan can be extended to a longer seasonal dataset for 9 or 12 months without any change in the dataset structure. The first step is to calculate the average of each metric for a whole week. For example, if the person had 3 sessions running, we have to average the running distance from the 3 sessions. The same for lifted weights from resistance training sessions. In this example, we want to combine distances and weights that have different measurement units and cannot be averaged. You can use 2 methods to calculate average scores. Using the average formula by selecting each relevant cell if the dataset is small, or using a pivot table method to calculate the average scores. Now we have the average distance and weight for each week, and the next step is to calculate a grand mean, which is the month average, and a grand standard deviation, which is the month variation score. The next step is to calculate standard scores such as Z-score, T-score and STEN score for each metric and each week. Check the standard scores formulas and add the weekly scores in the next columns. The score ranges for the Z-score are usually between plus and minus 3, for the T-score are between 20 and 80, and for STEN are between 1 and 10. The minus Z-score and low T and STEN scores mean a poor performance score. Now we can average Z-scores, T-scores and STEN scores of different metrics, such as distance and weights, and create a combined score for each week. Then we calculate the month standard scores through calculating mean, sum and standard deviations of all week's data. The main aim of monitoring training loads is to control the training volume and to prevent overuse injuries. There are a few training metrics that can be used for monthly training loads. Monotony is a variation in training load. Strain is the total training load, and the acute chronic work ratio, which is the week per month training load. Now you have all combined standard scores from monthly training loads regardless of the measurement units. Your scores are ready for creating a dashboard for different composite scores. Here, you have all the raw data from weekly training sessions and combined data to monitor the overall training loads. Thank you for watching. I hope this video has helped clarify how to combine data from different measurement units and answered your questions.